These, what you're hearing right now, are the turbulent radio waves captured by Juno as it entered the realm of Jupiter. When the Juno spacecraft was traveling through space, it was affected by the interplanetary magnetic field, a huge spiraling field that the sun's solar winds carry toward the planets. But when the craft locked into Jupiter's orbit, it changed environments. First it passed into the bow shock, the boundary where these solar currents are deflected by the furthest part of Jupiter's magnetic field. As it did, it experienced a sonic boom-like jolt of turbulence as it encountered the magnetosheath. Welcome back to this brilliant atlas of our universe. Today we're doing we're doing the outer planets. And we're going to start with the largest, most magnificent, Jupiter. Book is quite unwieldy. It's pretty big. Not as big as Jupiter, though. Here we have a magnificent portrait of the perspective from a moon of Jupiter. And to think that this here we have Amalthea. Jupiter's colorfully banded atmosphere is ever churning, ever changing. This would be our view of the colossal belted globe from Amalthea, one of its inner moons. Amalthea is a reddish, rocky little world, about 110,000 kilometers from the top of Jupiter's clouds. So, I would say maybe that's roughly a third of the distance between us and our moon, but nonetheless, Jupiter wouldn't be that much smaller if it were where our moon is. So incredibly massive. Its most prominent feature is, of course, the great red typhoon. The great red spot, a hurricane-like storm that has probably been raging for centuries. At lower left, there are 3 smaller white storm areas. The soft colors of Jupiter's bands shimmer against the black sky. These icy bands may be upwelling atmospheric gases composed of giant molecules. This king of planets is 1.5 times larger than all the other planets put together. It's also the fastest spinning. Pioneer and Voyager flybys of Jupiter told us much about the planet. The 2 Voyagers discovered its 14th, through 16th moons, but they found fewer moons in Jupiter's orbit than in Saturn's. The Voyagers also discovered Jupiter's ring system, as we can see, very faintly aligned. Here we see it as a thin line slanting along the equator. But they left many interesting questions. How did Jupiter get its rings? How does Jupiter's atmosphere support primitive life forms? If it does, what is the planet like beneath its massive cloud cover? Let's find out. Let's find out. Let's find out. Well, it would take 11, almost 12 of our years for Jupiter to orbit around the Sun. It's named after the king of the Roman gods. His name is a fitting one for our largest planet. Traditional sign for his lightning bolt. Gives the planet its symbol. That thing kind of looks like a 2 and a 4. And we could see its average orbitable. Any returning viewers are going to laugh at that mistake. Let's see how long I can keep that up. Its average distance is really, really far. See, I don't necessarily like to read numbers like that, because a lot of times it's vacant facts. It doesn't really have an impact when you say it's 778 million kilometers. At that point, it's so mind-boggling. It's really just out of our realm of imagination. But it's about 6 or 7 times further than we are from our sun. So the 5th planet holds a faint ring system and at least 16 moons in its gravitational grip. 4 moons are as big as small planets. The combined poles of Jupiter and the Sun also keep, and this is really, really interesting, I think, they also keep 2 asteroid groups called the Trojans and the Greeks. So, sorry, they're all Trojans. But there's a Trojan camp and a Greek camp. Let's see if they talk about the Lagrange points. One group moves along a 1/6 of the way ahead of Jupiter, and the other equally far behind. They bear heroes' names. Jupiter's tiny outer moons may be Trojan asteroids, trapped when they strayed too close to the planet. I don't think they will. The space occupied by these Trojan asteroids are what are called Lagrange points of gravitational theory and orbital mechanics. For some reason, in a 2-body system, there generally arises 3 more distinct points. Or 4 more, actually. I think one's out here. And I have an episode I did a while back. It's before I started taking this relaxing gig seriously. Just kidding, I just wasn't as good, I don't think. But I did do an episode about Lagrange points because I had just recently discovered them and thought it was one of those things that science only led hundreds, well, it's one of those things that a mathematician, Lagrange, I guess is really his name, French mathematician Lagrange, in the 1700s, I think, he determined that in a two-body gravitational system based on Newton's and perhaps Kepler's equations, there would be kind of gravity wells at these distinct, unique locations, and any objects flying too near these wells would interact with that location relative to the bodies, as though there were actually a mass right there. And that's what I mean by gravity wells, which is, I don't know much more than that, but if you're interested, then maybe you are an astronomer in the making. Perhaps it's some sort of interference pattern, like the way a magnet run along a wire, a closed metal wire. If it's run along it, it can use its magnetic field. Using that field will start to interact with the metal ions in the wire and induce a current of electric charge based on the interaction of the magnetic field with the metal. I believe it induces a counter magnetic field, and then those two magnetic fields interact with one another and cause a electromotive force on the electrons in the metal wire. It's a strange world we live in. The heavyweight champion of the worlds, Jupiter, right. Here we can see it's pretty awe-inspiring how much larger it is than our planet. It accounts for more than 2/3 of all material in the solar system outside the sun. It would take 318 Earths to equal Jupiter's huge mass. Gravity 2.5 times stronger than our own creates intense pressures in the swirling gases of its atmosphere. And the Voyagers found one bright ring flanked by a faint vertical extending ring and an even fainter gossamer one. These rings you can see right there. And here's what they think Jupiter is made of. We have at the very core molten rock, water, and ammonia. about 19,000 centigrade due to the intense pressure. Higher pressure generally means higher temperatures, and liquid metallic hydrogen is next. And then 10,000, it decreases a little bit to 10,000 centigrade. As you go up, less pressure, and then we get to liquid hydrogen. So we have molten rock, then water and ammonia, then liquid metallic hydrogen, then liquid hydrogen. And then we have at the top here, 15 it gets near freezing at 1500 degrees centigrade Celsius. Now it's touching space, so all its temperature, a lot of it can be dissipated in the upper echelons of the atmosphere, the upper tiers. It becomes liquid hydrogen, starts fusing in the upper 150 kilometers with water droplets, which form ice, and then ammonium hydrosulfide crystals, and then ammonia crystals at the very, very, very top. Sure, separated by density. In this pressure cooker level, gases would turn liquid and form a kind of a steamy slush. If you can imagine that, wow, it'd be so compact with pressure. It would be like, just like the steam in a sauna or in a hot tub or out of your tea or coffee. If you could imagine that being compacted and compressed into a liquid, scalding hot slush. Scientists even think, about halfway down to the planet's core, heat and pressure force the hydrogen to act like metal. Molten metal. Scientists think electrical currents in this zone may actually create Jupiter's giant magnetic field that we're about to see. And it's massive. It really is awe-inspiringly huge. Very large. But first, we have the giant red spot. Whirls 360 kilometers an hour, That's still upwards of 200 miles an hour. And this is actually a real picture caught by the Voyager spacecraft of the photons of light emitted from this giant red spot. On our make-believe journey through the solar system, we will pass safely through the asteroid belt, just as the two Voyager spacecraft did in 1978. First, they were flung out from Earth at a send-off speed of 52,000 kilometers an hour. Earth's and the Sun's gravitation gradually slowed them down. Eventually, the Voyagers entered the gravitational field of Jupiter, which, as they were slingshot around it, using precise calculations from the astrophysicists, or rocket scientists, aviation, aeronautical engineers, maybe. One of those really well-trained individuals. Earth's and the sun's gravity were no longer as impactful, I guess, on its speed, on its carefully constructed, engineered speed, as it zipped around Jupiter. It was flung away. It flew 1.5 years before reaching Jupiter, though. Because as all the planets have their own orbital speeds, they had to line it up precisely so that Earth was here and it was flung out. And then maybe it caught Jupiter all the way over here. But it had to travel very fast and very, very, very precisely to hit Jupiter, firing its thrusters at just the right moments for just long enough with just enough power to reach the giant planet and fall at just the right angle into its gravitational well. So, let's see. 1,300 Earths could easily be packed inside. A giant planet with giant surprises. 7 million kilometers out from Jupiter, Voyager 1 entered the planet's powerful magnetic field. 7 million kilometers. Wow. And Voyager safely crossed the boundary where the solar wind clashes with Jupiter's magnetic field in an electrically turbulent area called the bow shock. Jupiter's inner moons within the magnetic field are continually showered with high-speed charged particles, mostly protons and electrons. The current is spread too thin to harm the spacecraft, but except perhaps in the highly charged region between Jupiter and its moon Io, the movement of Io through the magnetic field sets up an electrical current of 5 million amperes strong. The current flowing in a 100-watt light bulb is only 1 amp. The electricity linking Io with Jupiter is gradually eroding Io's surface. Here we have the magnificent depiction of Jupiter's magnetic field. Gases explode out of Io's volcanoes and break up into charged atomic particles. Jupiter captures them along with surface particles, and they form an invisible donut-shaped electrical cloud around the planet. As Io circles Jupiter, the planet keeps the satellite a prisoner within this enormous energetic cloud. A major surprise from the Voyagers was that Jupiter, in fact, has a ring system. The faint ring stretches 52 to 58 kilometers, 1,000 kilometers above the planet's cloud tops. An inner halo ring is even fainter, enough thick, though thicker and more diffuse. And then there's a third, tenuous gossamer ring, which goes from about 58,000 kilometers to above the cloud tops, to almost the orbit. 58,000 kilometers above the cloud tops to almost the orbit of Jupiter's moon Amalthea. And what are they made of? Most scientists believe they're rocky debris from Jupiter's innermost moons, Metis and Andraste, which are slowly being broken up by the planet's gravitation. Gravitation, gravitation, gravitation. Jupiter's invisible magnetosphere is far bigger than the sun itself. If we could see it pulsing in our night sky, it would look about twice as big as the full moon. Oh, wow. God. From Earth, 700 million kilometers away, this thing would look twice as big as the full moon. That's so incredible, so incredible. That's just unimaginably big. So the bow shock here you can see the sun is a major furnace of millions of simultaneous nuclear reactions going off all the time, every second. So you can imagine there's a lot of output, a lot of thrust in a generally concentric outward direction. And Jupiter, just like the Earth but at a much larger scale, has this huge enveloping magnetic field protecting it from this solar wind going at 1.5 million kilometers per hour. And where the solar wind gets deflected by the sheer magnitude of Jupiter's intense magnetic field, that's just the bow shock. And then a magnetic tail stretches outward beyond the orbit of Saturn. Particles spun off from Jupiter's ionosphere collect in a thin sheet of electrical current, yellow. Near Jupiter, deadly radiation, thousands of times stronger than Earth's Van Allen radiation belts, batter Jupiter's major satellites. Jupiter's atmosphere is a churning sea of rising and sinking clouds of many colors, which really is interesting. It's like it's a super hurricane. Hurricane force winds. They tear at the clouds and add to their motion. It's been compared to an enormous boiling kettle of brightly colored dyes that can't be made to blend. The reason may be that these cloud cells contain different chemicals which originate at various depths within the lower Jovian atmosphere. For more than 100 years, astronomers have studied the Great Red Spot, a giant whirlpool of gas in Jupiter's southern hemisphere near the equator. They now believe it's a kind of weather phenomena unlike any on Earth. Jupiter's turbulent winds drive the gas, and the planet's rapid rotation keeps the 40,000 kilometer wide blob in a football shape. A prominent feature of Jupiter's atmosphere for at least the last 300 years, since Galileo was able to point his telescope up. Although I'm sure, I don't think he actually saw it, but it wasn't long after that we had finally grinded enough powerful lenses to make out that red spot. But it is truly a magnificent sight when you can look through. If you've had the fortune to look through a telescope and you see Jupiter, the one I've looked through is not large enough to discern the spot, but it is good enough to discern a little ball with red and white stripes. And then what's even more uncanny is that at any given time they might be in different positions, but there's 4 white dots that if you didn't know better, you would mistake for just background stars, but they're perfectly relatively lined up with the center of Jupiter in the telescope lens, and they're in the same plane. It's really, really cool. So they must be its 4 biggest moons, able to deflect enough light to be seen all the way through my telescope into my retina. Tens of light minutes away. So no one knows what makes it red, but it revolves along the rest of the cloud bands, but at a slower speed. It revolves along with the rest of them. Other cloud features sometimes catch up to the red spot and pass beneath it or around it. The spot also spins counterclockwise on its own axis at the rate of 1 spin every 6 Earth days. So if you were watching Jupiter from one of its outer moons, you could almost use the red spot as a clock with hands of clouds that dissolve and form anew. I don't know if you guys are interested, but I have a pencil. I have a number 2 pencil at my disposal. Might be a little better at tapping than my fingers. So let's try it out. Let's find out. I never say that at the right time. Below the Great Red Spot are 3 white oval storms. Astronomers watched them form only 40 years ago. Like the Great Red Spot, they are pretty much a mystery. That's funny. I thought they were going to elaborate, but no. There are many more of these storms. In 1973, space probe Pioneer 10 photographed one in the northern hemisphere, the Little Red Spot. But a year later, when Pioneer 11 flew by, it had dissipated. And then Voyager 1 saw its reappearance, or perhaps a new spot. Because of its strong gravity, Jupiter has kept much of its original atmosphere. The bulk of Jupiter's air is hydrogen, with helium making up about 10%. There are other gases as well, gases that may also, oh wow, let's let that sentence linger for a minute. In light of this view, I really like this. I wonder if the sun really does look that faint. If it's 7 times further away than Earth from the sun. I don't know. I know that's not a linear proportion, so I think it's probably something like 50 times. It might not be the square, but it might be like 4 times. So it might be perhaps all the way as much as 28 times dimmer to Jupiter than it is for the animals roaming Earth's surface. Just imagine flying around with storms 3 times the size of Earth. suspiciously heavy book. So, Jupiter's swift rotation causes bands of clouds called belts and zones, rivers of jet stream winds rushing eastward carry the high-flying light-colored zones, and at a lower altitude between the zones, dark-colored belts border jet streams that tear around Jupiter to the west. And the great red spot is the chaotic abyss between these two. Boundaries. These two films. These two membranes. Well, I forgot our previous sentence, how it started, but it ends with sorry, I can't say that without laughing. Have been in the original atmospheres of Mars, Earth, and Venus. And lucky for you, you could just tap back, depending on what you have your settings adjusted to find the dramatic beginning to that sentence. But as for me, I will march onward. Those gases include methane, water vapor, and ammonia. Wow, so it's negative 130 Celsius. And the great red spot, like all good hurricanes, is much cooler than its surrounding atmosphere. So we think as human beings that Jupiter probably lacks a solid Earth-like surface, and an explorer of Jupiter would first pass through a dense atmosphere of gaseous hydrogen that gradually changed to a strange, lifeless ocean of liquid hydrogen. Wow. And then 20,000 kilometers beneath this liquid layer, there may be a layer of hydrogen so dense it acts like a metal. And beneath this, Jupiter may have, we're broadly speculating now, but you know how much I love that, an Earth-size inner ball of rock and ice. Temperatures in this core may reach 25,000 Celsius, so the rock and ice are probably in a liquid state. And I suppose it's ice because it's not only water, but also ammonia, methane, and water. The rock being molten silicates, sand, or a bunch of used computer chips. Or a bunch of glass. Pressures here may reach 40 million times the pressure at Earth's surface. And Trump thinks he has it bad. But this is what Jupiter's interior actually is like. Then its metallic hydrogen layer probably carries the electric currents that produce the powerful magnetic field measured both by the Voyager spacecrafts. As Voyager gradually moved into Jupiter's shadow zone, it revealed more surprises. Toward the polar region of the planet, grand auroras erupted. Voyagers found that Jupiter's upper atmosphere is alive with lightning superbolts, and astronomers believe that the lightning may cause Jupiter's whistlers, or bursts of radio noise. And perhaps I'll add a little bit of that, if I can remember. Lightning bolts may also provide the atmospheric energy which triggers many of Jupiter's chemical reactions. Not far below the frigid cloud tops, there must be a region that is comfortably warm, a region of water, methane and ammonia gas reacting chemically, energized by the lightning. When these substances join, they can form organic molecules, the chemical beginnings of life. It is possible indeed that within this zone simple living organisms evolved long ago and have adapted to the floating existence within the clouds. Most scientists are not hopeful, but they do think that Jupiter's rapidly churning air has prevented the development of atmospheric life forms, since the complex molecules necessary for life would be swept down into hot regions of the clouds and be destroyed. If Jupiter's organic molecules have not combined and provided Jupiter with living organisms, they may enrich the planet in a less dramatic way. Rust-colored, they may well up and help color the great red spot, or redden some of the cloud bands. Is Jupiter a star that failed? Jupiter emits more energy than it receives from the sun. Twice as much. Tried to do that smoothly. As Pioneer and Voyager found. Could Jupiter have been much hotter in its early history, maybe even hot enough to warm its 4 moons, as the sun warms the inner planets? Here we have a really, really low resolution picture, but still, this is a man-made spacecraft so close it can take a picture and have it fill up the entire field of vision. That's terrifyingly beautiful. A Voyager camera captures 2 moons as they drift across a looming Jupiter. Sulfur colors Io innermost of the Galilean satellites, and Europa displays an icy crust. Like our moon, all four keep the same side inward, frozen that way in Jupiter's gravitational grip. So, the Galilean moons, much must mean that those were the four that Galileo saw, which might be the ones I was referencing earlier that I was able to see. So it seems it might have been hotter. Imagine the scene 4.6 billion years ago when the solar system was taking shape. Jupiter 2.5 times as massive as all the other planets combined, began as an enormous gas ball that had traced and heated up. Sorry, contracted and heated up just as the infant sun was doing. But unlike the sun, Jupiter had far too little mass to send its core temperature high enough to start fusion, so it couldn't create enough pressure, even though it has enough to make the core 20,000 degrees Celsius. But it didn't have enough to crunch those atoms together, those atoms of hydrogen and helium, and overcome the electric repulsion of the electrons, and even the strong and weak nuclear forces, and well past overcoming the gravitational energy. But instead of reaching the millions of degrees needed, the core heated up only a few tens of thousands of degrees. So it maybe perhaps glowed cherry red like a dwarf star, and for a while it bathed its inner moons in light and heat that faded as Jupiter slowly cooled. Probably only the inner moons formed as satellites at that time. The 8 small outer moons are believed to be former asteroids captured by Jupiter's intense gravitation. Voyager gave us our first few good views of the giant planets, 4 largest moons: Io, Europa, Ganymede, and Callisto. I have a little cousin named Callista, and I love that name. It's so cool. The moons discovered by Galileo in 1610, so the early 17th century. Looking through his telescope, Galileo saw only 3 moons in a straight line across Jupiter, 2 at the left and 1 at the right. Yeah, it's pretty beautiful. Oh, and then 2 nights later, he saw the 4th. The last one was behind the planet. That's funny. He realized that they must have been orbiting Jupiter. Ganymede's grooves, Callisto's rings. Europa's icy plates, and volcanoes on Io. Io eroded by radiation, jolted by arcs of electricity, squeezed and stretched. Io's surface reflects the moon's tumultuous state. The purple-plumed volcano on the horizon called Loki, and others like it, spew out enough sulfurous material to resurface the entire moon every million years. Wow. Fed perhaps by an underground ocean of sulfur, a distant volcano erupts into Io's airless sky. In the low gravity here, such fountains can shoot 300 kilometers high. Travel as far as New York to Chicago. Alright guys, that does it for Jupiter. And here I was expecting to get through all 4 gas giants. It's a marathon, not a race. Well, I really had a blast, and I really hope you did as well. I love these old books with these fantastic drawings. I'd rather look at a very well detailed artistic creation than a bland, smooth, overly high resolution CGI most times. But I'd like to say a big thank you to all my Patreon supporters before I let you guys go. Steve, you and Scrappy, thanks as always. Antoine, Debbie, Sean, and Kieran, thank you guys so much for donating at the $5 level. And all you other guys are just as awesome, and I love your support. So I have to make a big shout out to Mark, Matthias, Joshua, Andy, Dylan, Alexander, Dale, Simon. Thank you guys so much for your support. And then of course, Tim, Steve, Jody, Tristan, Ryan, and Sandy. Thank you guys for your donations off the Patreon site. I really don't know what else to say, guys, other than thank you, and your support is inspiring. So it really lets me know that I'm doing something that connects, and I'm just incredibly humbled and grateful that my own interests overlap so well with yours. But perhaps that's not a coincidence after all, because the world is amazing enough before we even start thinking about that we can develop this system of thought that helps us add 1 and 1 and make 2, and 3 and 4 and make 9. use it doing a number system based on how many digits we have. And by that we find relationships between shapes and geometric figures, and we abstract that from 1 to 2 to 3 dimensions, and of course much, much higher than that. Look at this page. This page somehow has dust on it. That's funny, I must have left it open. That's weird. I don't know. The world is stranger than fiction. It truly is. And I think it's a miracle, as not as unreligious as I am. I find it hard to believe that there isn't some ever I don't know, some unimaginable depth to our reality that we are just grazing the surface of with our science and our philosophy. And perhaps we get deeper and deepest with our experience. And perhaps, as well, the relations we have with each other that have allowed us to work in concert and work as a collective that have led to our positive being and our ever-progressive trail of history. Maybe that interaction and state of harmony, yet, of course not all the time, and we've had much tragedy to go along with it, but perhaps there is no upper limit to how beautiful and how deep of a sense of awe we can get if we work together and explore the cosmos around us. And I'm just glad I can maybe, perhaps, inspire you a little bit to let you know that I'm here, I'm doing this, and this is how I feel. And it's, at least for me, it's okay. It's okay to feel that way. As the great Jim James says, there will be bigotry, and there will be open minds, and there will be days of peace. You'll never have the time. I'm just honored you guys watched, so thank you, and have a pleasant, deep, fulfilling, satisfying, well-earned sleep. And as always, wake up tomorrow and just do a little bit more than you did today. Be a little bit better than you were yesterday. All those days add up. We all overestimate what we can do in 1 year, but greatly underestimate what we're capable of in 10. So let's go out there with a sense of camaraderie and be the best person we can be. And enough of those individuals like you and I will add up to something worth passing on to our future generations. Good night, guys.